Hi everyone, today I would like to present about electric circuit 1 and my group member are Ki Yonghyun and Lee Shuyu. First is agenda. This slide is divided to 5 parts, which are introduction, calculation, simulation result, analysis and discussion, and conclusion. Introduction. Nodal analysis is a method that provides a general procedure for analyzing circuit using node voltage as the circuit variable. Nodal analysis normally use the application of the Kirchhoff current law (KCL) with the formula current equal to high voltage minus low voltage divided by resistance according to passive sign convention. Next, mesh analysis is an application of Kirchhoff voltage law (KVL) which states that the summation of the voltage in any loop in a circuit should equal 0. The difference between the mesh and the nodal analysis is that nodal analysis is an application of a Kirchhoff current law which is used for calculating voltage at each node in an equation, while mesh analysis is an application of the Kirchhoff voltage law which is used for calculating the current. Then the calculation. Task 1. Here is the manual calculation. First, we use the Kirchhoff current law at the node V1. The current entering a node is equal to the current leaving a node. So I1 equal to I2 plus I3 plus I4. And we will get the first equation V1 equal to 8 plus 7 V2 divided by 13. Next, we do the Kirchhoff current law at node V2, I3 plus I4 plus I5 equal to I6, and we will get the second equation. And let equation 3 into equation 2, and we will get the answer V1 equal to 5.70 volt and V2 we will get 9.45 volt. After that is simulation result. Here is the simulation of the circuit. Then I will do it again at the produce. Then we will use the DC voltmeter to find the voltage at V1 and V2. Then after we run the simulation, V1 we get 5.70 volt and V2 we get 9.45 volt. And here is 4 ampere, 2 ohm, 4 ohm, 3 ohm, 5 ohm, 1 ohm, 2 ohm. And the voltage of the voltage source is 4 volt.
So this one is the question for the task 1 figure 2. The question asks us to find the I1, I2, I3 and I4. So in this case I use the mesh analysis by using the simultaneous equation. So the first equation is from loop I1, the second equation is from loop I2, the third equation is from loop I3, and the last, this is fourth equation is from loop I4. So I substitute the equation 2 into the equation 3 to get a new equation called equation 5, and also substitute equation 2 into the equation 4 to get a number 6 equation. So the fifth equation I substitute into the sixth equation, so I get a new equation called the seventh equation. So I also use the fifth equation to substitute into the equation 1, which is equation from the loop I1. So I get the add equations. So from 7 equation I substitute into the add equation, I can get a I2 equal to minus 0.622 ampere. So in this case I use more one decimal because I want to get a more accurate answer. So I use the I2 equal to negative 0.622, substitute into the equation 7, so I get the uh, I1 equal to 0.223 ampere. So I also use the I2 substitute to equation 5, so I get I3 equal to 1.178 ampere. So the last one I substitute I2 and I1 into the equation 2, which is this one from loop I2. So I get I4 equal to 0.222 ampere. So finally we get all the answer. So in this case I only get two decimal places because I want to compare with the simulation in emitter simulation.
For task 3, the circuit is more complex than the task before due to the number of meshes and nodes shown in figure 3. For this circuit, source transformation is applied for circuit simplification to modify this complex circuit by transforming independent current sources into independent voltage sources and vice versa. Consider the circuit in figure 3. The goal is to find the V0. We can see that the 6 ohm resistor is parallel to the 3 ohm resistor. Hence, we combine it to 2 ohm resistor. The 2 ampere current source has a 16 ohm resistor connected in parallel with it. Therefore, we replace this combination with a voltage source, which is V1 equal to 32 volt. The simplified circuit is shown in figure 3a. From figure 3a, the 16 ohm resistor is connected in series with a 20 ohm resistor. This can be replaced by an equivalent 36 ohm resistor. The 2 ohm resistor also connected in series with a 10 ohm resistor, hence can be replaced by an equivalent 12 ohm resistor. The 3 ampere current source has a 12 ohm resistor connected in parallel with it. Therefore, we replace this combination with a voltage source, which is V2 equal to 36 volt. The simplified circuit is shown in figure 3b. From figure 3b, the 24-watt voltage source has a 36 ohm resistor connected in series with it. Therefore, we replace this combination with a current source, which is I equal to 2 over 3 ampere. The 12 ohm resistor is connected in series with a 7 ohm resistor. This can be replaced by an equivalent 19 ohm resistor. The simplified circuit is shown in figure 3c. From figure 3c, the 36 ohm resistor is parallel to the 12 ohm resistor. Hence, we combine it to 9 ohm resistor. Since the 2 over 3 ampere current source has a 9 ohm resistor connected in parallel with it, therefore we replace this combination with a voltage source, which is V3 equal to 6 volt. The simplified circuit is shown in figure 3D. From figure 3D, we apply Kirchhoff's voltage law to find the V0. V0 is equal to 28 volt.
So analysis and discussion. For task 1, figure 1, the value of the voltage in the simulation is same as the voltage calculated by manual, which are V1 equal 5.70 volt and V2 equal to 9.45 volt. Nodal analysis is used in the question. The theoretical value of the voltage is same as the value of voltage calculated by the simulation tool. So for the task 1, figure 2, the value of mesh current is same as the mesh current calculated by the manual, which are I1 equal to 0.22 ampere, I2 equal to negative 0.62 ampere, I3 equal to 1.18 ampere, and I4 equal to 0.22 ampere. So in conclusion, if node is more than the mesh, so we use nodal analysis. On the other hand, if mesh is more than node, so we use mesh analysis. Last is source transformation. Source transformation is a method to simplify the complex circuit by transforming independent current into independent voltage. Okay, that's all from our group. So thank you.